Hello everyone, welcome to Tom and Jerry Run and Catch. This is the course project of COMP3111. I'm Chong Samuel. I'm mainly responsible for function A of the project, which is apply the MSD algorithm to generate the maze automatically. So let me first briefly explain how the algorithm works. Okay, let's start with a 4x4 grid. To generate a maze in such a grid, the first thing we need to do is to select an entry point. So right now we have an entry point here. The blue dot means the current location, and the cell becomes green means that it is being visited. And right now what I have to do is to randomly select direction to move, but I cannot select left, I cannot select top because it will be out of order. So my only choice is to right or bottom. So I select bottom, I select right, I select right, and I select right. So at this location, I can only select top or bottom. I select top, I select left, and go left again. So at this location, I cannot select any cell because the top is out of border and the left, the right, and the bottom has been visited before. So I cannot select them, select this cell. So what I have to do is to going back, follow the route. So I'm going back, and then going back. So when I'm back to this location, I can select to move bottom again. So I move to the bottom, I move to the left, I move to the bottom again, and then left. Okay, we meet the same situation here, and then we're going back to here, and then we have visited all the cell. So next, what I have to do is to remove the wall on the path, which means this. So you can see that all the walls on the path has been removed. And now I remove the arrow. You can see that a maze has been generated. So with the brief idea, now I can demonstrate how do I generate the maze map. First, I will initialize the map in grid format like this. The white are the clear vertex and the gray are the words. You may find there is a strange part here, and this is for generating the multiple path. As the MSD algorithm can only generate one single path maze, so my solution is the following. I will run the algorithm once on the left half of the maze. Yeah, you can see the maze is generated on the left. Then run algorithm once again for the right half of the maze. At this stage, the maze generation is almost done. The only thing left is to generate the path between entry and the exit. We can achieve this by destroying the walls in the middle. So if I want 6 one-way path, the walls in the middle will be destroyed 6 times, just like this. And now I will pass to Lucas Chen to explain more on function B, finding the shortest path in the maze.
Hello, my name is Lucas Chen, and I'm going to introduce and explain the implementation of function B. So here is the main class for function B, which is called base SPT. So in the constructor, it takes the graph, the binary graph of the maze, which is in the type of integer 2D array. So there are 3 algorithms available in this class, which are depth search, A star, and breadth search. So here is the method to find the shortest path and possible paths, which I extract concepts and algorithm of finding the paths. So we can choose either one of the algorithm, and the default algorithm is A star since it performs the best. So below are the helper function for me to implement the path algorithm. So in this class, I implemented a class called path window, which is the subclass of window and JFrame, since window is a subclass of JFrame. So the shortest path and possible path will be found once the path window instance is constructed. As only the algorithm depth search can find all the possible paths, I need to first set the algorithm to DFS and then find all the possible paths as well as the shortest path. So here's the method to display the path, and it takes the input to indicate that whether the possible path to display or not. And here's the method to write the path data into the CSV file, which is indicated at path.csv. So here's the result. As you can see, there are a maximum of 5 possible paths to be displayed in this maze window. And the orange color indicates the turning point of different paths. And the corresponding data will be written into the path.csv, which is here. So as you can see, there are named in this path data, which is SP or OP. They stand for shortest path and other possible path, respectively. So in the other possible path data, there are color indicated the data. And here is the coordinates of the vertex, which is in row and column order. So the length of the corresponding path will also be written into the CSV file. So let me show the shortest path display. As you can see, there are only one path displayed in this window, which is indicated as in green color. So it is the shortest path between the entry point and exit point. And the detail will be changed. Shortest path is indicated here. Here is the end of my introduction explanation of my implementation. Thank you. So in the following, please let me pass the time to David.
Hi, I'm David. I'm the one who in charge of function 3. In my function, I designed the game logic. A simple example is that when Jerry get the crystal, with the crystal power, Jerry can faster than Tom. And our creative idea is that we add background music to this game according to the action or situation. Like Tom is very close to Jerry. The background music would become very fast and very exciting. Here's the demo. Let me be wonderful. When I type 4, it will be my part. Here is a little story indicate that which color of the square is which object is it. Let's get started. Listen, I am going to check Tom. Sorry. Yeah. Almost look. Hurry up. Although I'm loose in this game, but it's quite fun because with the music, the game is exciting. And how our team work together is that we have a weekly meeting to talk about what we have done and what we're going to do and what challenge we encounter, which is a Scrum discussing. Yes. We do have an impressive story in our team, which is when one of our team members run the program, his laptops break down. I don't know why. Maybe there's some bug in the code. Anyway, he buy the new one. He have to buy the new one. And what I have learned is that I learned how to use GitHub and Java. For a beginner to the GitHub, I was quite confusing, and now I think I know how to use it. Thank you.
It's the Tom and Jerry Kids.